Welcome! This narrated set of notes provides an overview for Module 3, which focuses on performing calculations with formulas and functions. Here are some important takeaways in Module 3 that may be new to you: making workbooks user-friendly, logical functions, lookup functions, and what-if analysis. Other module topics you will recognize from your prerequisite coursework. Regardless of your comfort level with the features presented, you will need to read all of the presented white pages material so that you understand the context for completing the step-by-step instructions. So before we dive in, here are the textbook typos to correct in your textbook before starting the module. On page 3-30, Instruction 6, click the running total, says the running tool. So change tool to total. On page 3-42, Instruction 4, after VLOOKUP, you will need to click on the OK button. So add that to your instructions on page 342. If you come across other typos, please post them to this week's open discussion forum. Here are the Module 3 learning objectives. In Session 3.1, which focuses on formulas and functions, documenting a workbook is an important feature. A workbook with many calculations can be challenging for the author to write and for others to read and use. In order to help everyone, it is important to list the formulas used in the workbook and to explain the assumptions behind those formulas. The workbook documentation should also include the definitions of key terms to make it clear what is being calculated and why. You will be translating equations into functions. You will be doing calculations with dates and times. Some of the calculations will include constants. Your textbook discusses how best to present them. We will be taking a closer look at how Excel stores dates and times in a manner that allows us to compare them and use them in numerical calculations. You will be extending data and formulas with AutoFill, with and without formatting. You will use the library functions, and you will be doing some calculations using statistics, the measurements of central tendency. For Session 2, the highlighted topics are using logical functions. We will take a look at using an if. We will also look at retrieving data with the VLOOKUP tables. And you will be practicing with what-if analysis through trial and error and goal seek. Here is the visual overview for formulas and functions in Session 3.1. It's a good idea to review this before starting. The scenario for Module 3 is that you are going to provide some data analysis for a customer call center, also known as a help desk, for Evergreen Fidelity Insurance. Your manager has collected data on which you will perform calculations and analysis. Take time to review the visual overview before starting. Then review the quick check questions at the end of Session 3.1 that you will be asked to answer. As you work through the module, note the page where the quick check topic is discussed, so it is easy to review when you are ready to complete those quick check questions. Here is a copy of the formulas and key terms from the workbook module. Now, when I was looking at this workbook, I was not sure about that KPI, which stands for Key Performance Indicator. Also note that when we talk about statistical measurements, we refer to them as the mean, median, and mode. Excel doesn't use the term mean, it uses the term average. so we see the two of those together under key terms. It also explains the workload, how it calculated the probability of waiting, and don't be afraid of that formula. We don't have to enter it. It's already been done for us. But keep in mind, even if you were the one that created this workbook, if you had to put it down for a couple of weeks and come back to it, this documentation of the formulas and key terms would be helpful to you as well. To make the workbook user-friendly, it is helpful and professional to provide a worksheet like this in your workbook. Don't forget that some equations will use constants. These are also known as fixed values. Be sure to read the insight box provided on deciding where to place a constant. This is on page 3-6 in your textbook. Calculating with dates and times. One thing that may be surprising is that in order to allow dates and times to be used in calculations and comparisons, Excel stores dates and times as the number of days since January 0, 1900. Full days are a whole number and partial days are a fraction, such as 0.5 for a half day or 12 hours. Storing dates and times as numbers makes it easier to calculate time and date intervals. You will explore this in the module by determining customer hold times and length of calls when the customer is being assisted by an employee. Here are some of the date and time functions provided by Excel. You will find this figure 3-18 on page 3-24 of your text. Many workbooks include the current date. You will use the Today function to display the current date in a worksheet. The Today function has the following syntax. Recall that the term syntax provides the rules for using and writing functions and formulas in Excel. The date displayed by the Today function is updated automatically whenever you reopen the workbook or enter a new calculation. Autofill formulas and data patterns. One way to efficiently enter long columns of rows of formulas and data values is with autofill. Autofill extends a formula or a pattern of data into a selected range and is often faster than copying and pasting. Use autofill to create a series of numbers, dates, or text based on a pattern. To extend a series of data values based on a pattern, enter enough values to establish the pattern before dragging the fill handle or using the double click to fill a larger range. Some options. By default, autofill extends both the formulas and the formatting of the initial cell or cells. But you can extend only the formulas or only the formatting if you choose. Use the series dialog box for more complex autofill patterns. This is covered in detail in the module. Here are some frequently used Excel functions. Rounding, you can round up or round down. You can find the min and max of a range of values. And statistical functions for the measures of central tendency, the mean, which you will find listed as the average in Excel, the median, and the mode. You can nest functions. Nesting functions are when you have one function inside of another function. Review this section carefully. Excel provides some terrific visual cues and screen tips when you're working with nested functions, and I encourage you to take advantage of using those. Another important consideration is how the data is stored. Be sure to review the section on the role of blanks and zeros found on page 323. It provides a good example comparing the use of blanks versus zeros in a data set, and why you need to be sure to check your data for this so that you don't make false assumptions and therefore erroneous calculations with the data. Here are some common error values. Now I know you like to think you're never going to see these, but I'm pretty sure these will happen to you. And I've highlighted the common ones. Division by zero. This happens to me a lot when I use AutoFill and I forget to use an absolute cell reference for my divisor. The name, when Excel doesn't recognize text in a formula or function, or you mistype or misspell one of them, you will get this name error. Notice all the errors begin with a hashtag. And then finally, the value error. This is when you have a wrong type of argument in a function or formula. So what exactly does that mean? Well, if it's expecting a number and there's text there, or a date there when it's expecting a specific kind of number, you will get a value error. Errors indicate that some part of the formula was entered incorrectly. Errors themselves might not be particularly descriptive or useful when you're trying to read what Excel is complaining about. To help you locate the error, an error indicator does appear in the upper left corner of the cell with the error value. Look for this table on page 3-26, and I recommend that you dog-ear this page for when this happens to you and you need to figure out what went wrong. In session 3.2, you will look at absolute and mixed cell references, and these are definitely helpful when you're extending formulas. This session also introduces logical functions, vertical lookup tables, and what-if analysis. Calculating running totals with the Quick Analysis tool. The Quick Analysis tool appears whenever you select a range of cells, providing an easy access to the most common tools for data analysis, chart creation, and data formatting. It is an excellent tool for doing useful calculations and entering Excel functions. Here is what this is going to look like in your module. You'll want to select the totals card and then scroll to the very end for the running total with the vertical indicator. Notice we have a blue running total. That first one is for horizontal totals, but in the module you'll be using a vertical total. So you will want the very last one in the row. Take your time and be careful when working through the instructions for this. Cell references are likely a review. Keep in mind that they have an effect when you're copying and autofilling formulas. So let's just do a quick review together. Relative cell references are just the column and the row indicators. So perhaps in cell D1 we want to total cell B1 plus C1. Then we could drag that down the column and all the subsequent rows would update correctly relative to their row. Absolute cell references remain fixed even when the formula or function is copied to a new location. Absolute references include the $ before both the column and the row designation. For example, if you were computing an average or a percentage of a total, you would use a fixed cell or an absolute cell reference as the divisor. Mixed cell references hold either a row or a column fixed. So we see here either we're holding the column fixed with $A and letting the row reference change, or in the second example we're holding the row fixed as row 1 and allowing column to vary. Remember that you can easily cycle through relative, absolute, and the mixed cell references and formulas by selecting the cell reference in the formula and pressing function key 4 while you're in edit mode. Working with logical functions, we'll take a look at the if. Remember that functions and formulas always start with the equal sign. Logical functions build decision-making capability into a formula. The results of logical functions are either true or false, so these always provide a yes or no type answer. There are many different logical functions, and the if is a popular one, so let's look at that. Here is an example. The first part of the if, again starting with an equal sign to indicate it's a function, use the keyword if and then a parenthesis, and do not leave a space between the F and the parenthesis. It would confuse Excel. The first part is the logical test. In this example, we're checking if cell B7 has a greater stored value than what is stored in cell H5. If it does, we're going to put yes in this cell. But if it doesn't, then the value is false. The result, we were going to put no in this cell. In Module 3, you will practice with the if statement for checking whether or not the wait times are too long for a customer who has been put on hold. And this is on page 36. I'd like to do a little demo using the dialog box. So I've opened up the workbook and I'm looking at page 336 in Module 3, and we're asked to calculate that key performance indicator of whether or not or how long a customer has been put on hold. Have they exceeded the hold time goal? So in column L, we see we're subtracting B28, that's our 15 seconds goal, as an okay amount of time for a customer to be on hold. H5 is the actual hold times that we calculated. So L5 here shows us -10. And this is because the hold time for this call was 5 seconds, which is really good hold time. I wish that happened to me when I made calls to a company. And that means it was 10 seconds faster that they were answered than our acceptable wait of 15 seconds. In our KPI, this key performance indicator, in cell M5, we're going to use an if to find out through all of these and count up how many of the calls exceeded that 15-second wait time. So I'm clicking in cell M5. On the ribbon, I'm going to select formulas, logical functions, if. Now I encourage you to work this way at least in the beginning and absolutely when you're dealing with nested functions so that you can see exactly what you're entering values for. The logical test here is, was the result in L5 greater than 0? So if it was greater than 0, it meant they waited longer than the 15 seconds. If that's true, then our value if true that we want to enter here is 1. Why 1? Because we're going to count all of the rows where the customer had to wait longer than 15 seconds. Now if they didn't have to wait longer than 15 seconds, the value stored in column L will be less than 0. And if they waited 15 seconds, the value stored will be exactly 0. So that would be acceptable as well. So we're just looking for those values that were greater than 0, and false will be less than or equal to 0, acceptable wait times. And in that case, we're going to enter a 0. The reason we're using 1 and 0 instead of true or false here is that we're going to easily then count how many ones are in this column. Say OK. And we want to extend this down the column. So I'm going to just go a few down. And now I want to fill without formatting because I like those banded rows. And now once I have the banded rows restored, now I can just double click and let Excel fill the rest of the column. Back to our notes. Here is a table of the relational operators that we can use for comparison. Don't be confused by the use of the equal sign again. We need to put the equal sign to indicate that we're putting a formula or function in a cell. But when we check for equality, we also use the equal sign as the operator. The not equal to is a less than followed by a greater than symbol. Formatting input, calculated and output values. Formatting cells based on their purpose helps others correctly use and interpret your worksheet. In addition to the headings, the Cell Styles gallery includes cell styles to format cells containing input, calculation, and output values. So we can color code these a bit to give visual cues to whoever is using our workbook as to the intent of that particular cell. Using a lookup function. Lookup functions find values in tables of data and insert them in another location in the workbook, such as a cell or in a formula. A lookup table organizes numbers or text into categories. The syntax for the VLOOKUP function is as follows. We would use an equal sign in front of VLOOKUP, and then in the parentheses, the lookup value, the table, and the column index. If we're doing an exact match of value, then the range lookup is set to false. Let's take a look at this being used in Mod 3. Here we are in the Support Calculator worksheet. The call center lookup table has the following columns. The number of operators is in column 1. The hold probability, the expected hold in seconds, and the failure rate. Notice that the number of operators is stored sequentially. That's a requirement of a vertical lookup table, that they're in sorted order. To use the vertical lookup function to determine the hold probability, we're going to click in cell B18. On the ribbon, we click the Formulas tab, and then we're going to Insert Function, and in the Select a Category, we want Lookup and Reference. We're doing a vertical lookup because this table is listed vertically, so each number of operators here is unique. And you can read about why those were the numbers we started with in your textbook. But two things to note, they're in sorted order and this table is vertical. So we're using vertical lookup, not H for horizontal, V for vertical. Say OK. Again, by using the dialog box, it's pretty clear and well explained what each of the input arguments are being used for. So the first thing is the lookup value. And in this case, we're to type the absolute cell reference of B7. So I'm typing $B, $7. The table array is absolute range E5 through H32. So again, we use the $E, $5 through $H, $32. The column we're interested here is the hold probability. That's column 2. And the range lookup is false because we're looking for an exact match. Now my lookup value is based on a 25, so this is not a range of values. It's an exact match for 25. I say OK. And with 25 operators, the probability of waiting on hold is 30%. Back to our notes. What-if analysis with formulas and functions. A what-if analysis lets you explore the impact that changing input values has on calculated values and output values. One way to perform a what-if analysis is by changing one or more of the input values to see how they affect the calculated results. To perform what-if analysis by trial and error, we change the value of a worksheet cell, an input cell, and then observe its impact on one or more of the calculated cells, called the result cells. And we do this until we achieve the results we're looking for. So the trial and error method requires some guesswork as you estimate which values to change and by how much. You will practice this in Module 3 by changing the number of operators available. GoalSeek automates the trial and error process by specifying a value for a calculated item. This sort of works backwards. We specify the outcome we're interested in achieving, and then GoalSeek will make adjustments to the input cells in order to achieve it. So for instance, if we know we need to reduce labor cost, but we're not sure how much we need to reduce labor costs in order to achieve a particular net profit, we can use GoalSeek, set the net profit to what we're trying to achieve, and then see how that recommends a reduction in our labor costs. You will explore using GoalSeek by discovering how many operators will be available to accept calls at any given time with a staff size of 30. This is the end of the highlighted notes for Module 3. If you have any questions or wish to discuss any of these features, please post to this week's open discussion forum.